Hello everybody, and welcome back to the next installment in our physical material series. In the previous clip, we've created this awesome looking raw wood material, and in this clip, we're going to be turning it upside down by adding a varnish coating to it, okay? And it's going to look like a completely different wood material just because of that varnish. So we're super excited about this one, and we can't wait to get started. So let's get started. Right. So we're going to be creating the varnish effect with the help of the new built-in Clearcoat layer. And this layer is a pretty awesome thing that we hope you're going to be using for a lot of your materials. And we're really confident that it's going to make your life easier whenever you're going to want to create the Clearcoat layer effect. Now, before we actually start creating the material, let's first talk about what a Clearcoat layer actually is. Now, a super typical use case of Clearcoat layers can be found in the car industry. It's typically the first example people think of when they hear the word clear coat. So with car paints, you typically have a rougher base layer, which, because it's rougher, it doesn't feature that shiny reflective look. And then on top of it, you have a clear coat layer applied to it. Well, technically for cars, they typically apply a couple of clear coat layers, but they can be easily summarized by a single clear coat layer because the differences between them are just so tiny. But anyway, the point is that the clear coat layer that's applied on that base, the clear coat layer then creates those nice shiny reflections that car paints typically feature. No, but that isn't the main reason why they apply a clear coat layer to car paints, mind you. Typically that is done to also protect the underlying layers of paint from weathering. Right, so that's the general idea behind the whole clear coat ordeal. It's a thin strip of clear, transparent coating that you apply on top of your base material. Now, car paints aren't the only materials where we apply this sort of protective coating, protective film, if you will. Because another example would be applying varnish to the different kinds of wood materials. And that's exactly what we'll be doing here in our case. So now, if you think about it, a varnish is basically a thin, clear, and transparent protective coating that we apply to raw wood materials to protect them from weathering. But not only that, they add that nice looking reflective property to the wood as well, plus a clear coat, if it has some sort of an absorption property, can also get you that nice stained look. Now, a pretty important distinction that you absolutely should remember is that the clear coat layer is a separate layer that gets applied on top of the base layer. Now, in the context of the material that we were creating in the previous clip, the base layer is basically all we have so far because our diffuse texture here has been defined in the base layer, right? Then the roughness, so the way that our reflections behave, were also defined in that base layer. And then the bump as well, and the IOR as well. Now we're not using any anisotropy, always a mouthful, and we're not using any translucency. So, you know, we're not going to mention these parameters here because we haven't used them. But for all intents and purposes, the material that we have in front of us has been defined in that base layer. So what we're going to do here to add that varnish effect is we're going to add a clear coat layer on top of that base layer. So hopefully that makes sense here. Now, if you look at the clear coat layer grouping here, you're immediately going to see that by default, you have most of the parameters here grayed out / inactive. And that is by design, because by default, whenever you create a new Corona physical material, the clear coat layer will come in with its amount set to 0, which basically means that the clear coat layer is by default disabled. Now, if you up its amount here to anything above 0, that means that the clear coat layer is going to become active, and so are going to, the same is going to happen with these parameters here. They're going to become active, and you'll be able to tweak them, okay? Okay, so what we'll do next here is we'll start developing our varnished wood material. And as we do that, we'll obviously be tweaking all of these parameters in here. And as we'll be tweaking them, we'll also be explaining what each and every one of these do. Okay, starting with the amount parameter. So the amount parameter sets the strength of the Clearcoat layer. And right now we have it set to its maximum amount, which is an amount of 1.0. And as you can see on the rendered image here, the Clearcoat effect really comes in strongly, right? It has this very pronounced look. It almost has a very thick quality to it, right? Like you're applying the Clearcoat layer in a very generous amount. So if we start lowering the amount here to say 0.5, well, then you're going to see that the effect becomes, the layer itself becomes less stronger, it becomes less pronounced. It's almost like you're applying a much thinner Clearcoat layer on top of that base material, right? But it's obviously still there because you can see that the highlights, the reflections here are still there, they're just a lot less strong. Now you can also use a map to map the amount parameter, which basically means that using the map, you're going to set which parts of the material have a stronger Clearcoat layer applied, right? And which parts have a less stronger Clearcoat layer applied. But for the type of varnish that we'll be creating here, we'll just stick to a non-mapped amount parameter, and we're actually going to up it back to its maximum amount of 1.0, just because for the type of look that we're going here, we want the varnish to really look like it's been generously and sort of somewhat perfectly applied on top of our raw wood material, right? Right. And that's pretty much all that there is to the amount parameter. It's all in all, it's really straightforward, and we'd really encourage you to play around with it because you can get some really great results just by playing around with the amount parameter. Next up, we're going to talk about the IOR parameter here in the Clearcoat layer. And one of the most important things that we can say about it is that the index of refraction parameter here in the Clearcoat layer only affects the IOR of the Clearcoat layer, right? Because if you go under the base layer here, you're going to see that the base layer has its own IOR parameter, which controls the IOR of that base layer. But because the Clearcoat layer is a separate layer, it needs to have its own IOR parameter, right? Right. And varnishes, because we're creating a varnish sort of Clearcoat layer here, varnishes typically have an IOR value somewhere between 1.3 and 1.5. So we're going to input a value of 1.35 here, okay? And that should do it for us here. Okay, then next up, let's talk about roughness. And roughness is really straightforward because we already know what it does. Because if you've ever created a material, you already know what roughness / glossiness does. So if we up the roughness parameter here, you're going to see that the reflections on that Clearcoat layer are going to become rougher, more diffuse, if you will. Now, for the type of varnish that we're going here, we don't want it to be mirror-like, but we still don't want it to be too diffuse. So we're going to go with a value of 0.2 here. I think that should be a very good base for us. So now our varnish layer on top is quite mirror-like, right? The reflections are not so rough, but at the same time, they are just a little bit imperfect, right? Now, to emphasize the imperfections, we're actually going to bring in a roughness map here for the Clearcoat layer specifically. So as you can imagine, we've already prepared one, and it's just this sort of splatter map, if you will, okay? And it's going to really add some extra realism to our Clearcoat. So we're just going to apply it, slot it into our Clearcoat roughness slot here. And now, just by doing that, you're going to see that the effect really comes in nicely. You can see that now we're breaking off those reflections because some parts of that Clearcoat are now rougher, and some parts are more glossy, if you will. But I do think that the effect is just a little bit too strong here. So let's go under our maps options here, and let's just set the Clearcoat mixing coefficient to 30. So this is all standard material tweaking stuff, right? We're just essentially saying that we're mixing less of this map with the value that we've inputted here, right? So this is all pretty standard stuff. But I think at a value of 30, we've actually hit it. We've set it pretty well here. So the imperfections are there, but they're not too apparent. So that's the effect that we like here. We just want to introduce a little bit of weathering here. Okay, great. So our material here is starting to look pretty great, right? It's starting to look pretty cool. But there's still a couple of parameters that we can still tweak here to make it look even cooler and, even more realistic, if you will. And so the next parameter we'll talk about here is the bump parameter, because the bump parameter inside that Clearcoat layer is a really important parameter that can really alter the look and feel of your material. Now, before we actually start plugging maps into the bump slot here and getting things all fancy and whatnot, let's try and understand how the Clearcoat layer's bump works in relation to the base layer's bump. So to do that, let's start by talking about that base layer again. So we've already established a couple of times by now that the base layer has a pretty strong bump effect happening. As you can clearly see, the wood grains are indented, right? They're catching highlights really nicely. There's just a lot of those bump imperfections happening on that base layer. But now, on top of that base layer, right, we're applying the Clearcoat layer, and the Clearcoat layer has no bump effect defined, right? We're not plugging any maps into the bump slot here, right? And if you were to now put your hand on this material that we've created, on its surface, right, you would notice that the surface is completely smooth, okay? Now, that shouldn't take away from the fact that the base layer is still bumpy, okay, because it is. But the Clearcoat layer that we're applying on top, because it has no bump, it will sort of act as a Clearcoat layer that will end up producing a smooth surface, okay? Now, if you wanted the Clearcoat layer to follow the bump imperfections of that base layer, what you would have to do is you would have to take the base layer's bump map. So this is, for us, this is this map right here, and you would have to plug it into the Clearcoat layer's bump slot, okay? So as soon as you do that, you're essentially saying, hey, Clearcoat layer's bump, you should follow the base layer's bump, okay? And so if we zoom in on our rendered image here, you're going to see that that is indeed what is happening. So our Clearcoat layer now is following the imperfections of that base layer down to a T, right? Now, to have it completely match the strength of the base layer, you would also have to adjust the bump strength here to match the one in the base layer, right? But because we're creating a bit of a different effect here, we won't be doing that. So essentially what we're doing here is we're saying, hey, the Clearcoat is going to follow the bump of the base layer, but it will still even it out maybe just a little bit, so the effect won't be quite as strong. Now, if you were to put your hand on this surface right now, yes, you would definitely notice there is a Clearcoat layer applied to it, but the Clearcoat layer would follow the unevenness, that's a funny word, but it would follow those bump imperfections of the base layer, right? So this surface would not be smooth if you were to touch it right now, right? Right. But now Clearcoat layers, sometimes they have their own imperfections as well. So sometimes they follow the base layers, imperfections, but then they also have some imperfections of their own, right? So maybe this violin fell to the ground, it got bruised and stuff like that. So the Clearcoat layer that's sitting on top there could have its own imperfections. And now, if you still wanted the Clearcoat layer to follow the base layer's bump, but you would still like it to have some of its own imperfections, what you could do is you could bring in for example, a Corona color mix map here, and then into its bottom slot, you could plug in the base layer's bump, okay? And then you could bring in a different imperfection map, right? So we're going to bring in just one of the dirt maps that we have available to us here, right? And we're going to plug this map into the top slot of our Corona mix map / shader here, right? And now I'm going to change the mix operation here to something that's a little bit more fitting. So I'm going to use multiply. Now if I lower the mix amount down to 0, you can see that what we're doing essentially is we're taking the base layer's bump, right? And now if we start mixing in this extra imperfection map on top of it, we're adding additional imperfections on top of that base bump. Right, now if we were to plug this thing into the Clearcoat bump slot here, you would notice that now essentially what we're doing is we're saying that the Clearcoat should follow the bump map imperfections of the base layer, but then it also has some additional imperfections of its own, right? And so that's what happened. That's what's happening here. Now, clearly, these are really small details, so hopefully the compression is not killing it for you. But we're just seeing some extra details being added on top of our Clearcoat layer here, essentially. Now, sometimes you do want your Clearcoat layer to be applied in a way so that it smooths out the surface, right? But then again, you still want it to have some imperfections of its own. Now, if that's the case, what you could do is you could just delete this Corona Mix map here. And what you could do is you could just plug in a totally unique, a map that's different than that base layer's bump, right? And just plug it into the Clearcoat bump slot. So now what you're essentially doing is you're saying, hey, Clearcoat, you've been applied in a manner so that you smooth out the entire surface, right? But at the same time, you have some imperfections of your own. And that's exactly what we've set up here right now, right? Now the effect is a little bit too strong, so let's dial it down. Maybe we can use a value of 0.25 here for our bump map effect, and that's going to help us add some extra realism to our material here, because now we're adding some slight imperfections to that varnish that we've added on top. Right, okay, so now we're really adding some really cool details to the material, but there's still one more parameter we need to talk about, and this is one of the key parameters for the Clearcoat layer that can drastically change the way that your material looks like. Okay, so that is the absorption parameter. Now, the Clearcoat layer is indeed a very thin layer that gets applied on top of that base layer, but the Clearcoat layer can still absorb light differently, and that's what this absorption parameter here is for. Now, instead of us talking about what the absorption parameter does, let's just demo it, because the demo is going to be pretty telling, so hold on to your chairs, people. So we've brought up the color picker for the absorption color here, and so we're going to set the absorption color to be this sort of brown color, and immediately you'll be able to see that our material now looks completely different, right? Now, before we say anything else at this point, we do need to mention that the absorption parameter is a physically accurate, physically realistic parameter, okay? So the changes you make with it are the changes that you would expect to be there in real life as well. Right, now as far as what is happening with our material here goes, well, the explanation is rather simple. So the Clearcoat layer, even though this is a very thin layer, it is still a layer of its own, and it is transparent, and it can absorb light differently. So by setting the absorption to be, well, different than the default white, you're going to get this sort of absorption effect happening. Now, in our case here, we're using the absorption to essentially emulate all the different kinds of layers that such a violin would have in real life, because in real life, such a violin would be made up of like 7 or 10 different kinds of coatings, okay? And some of those coatings would also be a bit colored, they would be pigmented. Now, obviously, we're only dealing with a single Clearcoat layer here, but using the absorption parameter, we can easily emulate that effect by playing around with it, right? So now we've essentially pigmented our Clearcoat layer here. We've given it a shade, and we've also made it absorb a bit more light. And that means that it's also gotten a bit darker. So then what we basically ended up doing by tweaking the absorption parameter here in our specific case is we've sort of simulated what happens when they treat these types of woods with, all the different kinds of coatings, because again, the violin body gets treated with like 7 to 10 different kind of coatings, some of which are pigmented, colored, right? And so as you can see, just by using the absorption parameter, we can emulate those effects. Now, if we were just to add a clear coat, if we were dealing with a material that simply has a basic clear coat layer applied to it, and that layer has some sort of pigmentation or absorption or stuff like that, then we could also just simply set it accordingly to what is happening with the real material. And in that case, we wouldn't be emulating anything. We would just be recreating what is actually there in real life. So as you can see, the absorption parameter can be really a versatile parameter for you. And because the absorption parameter is a physically accurate, physically realistic parameter, it'll affect your material in a very realistic way. So let's quickly just demo what we mean here. So I'm going to drop the base layers level here down to 0. Then I'm going to up the refraction, effectively making our material refractive here. And then if we up the absorption value here so that we let more light pass through that absorption layer, through that clear coat layer, you're going to see now that because that clear coat layer on top is absorbing light differently, it realistically affects the look of your material. So in our case here, because the clear coat layer is absorbing light differently, all the layers below it will be visually perceived differently. And as we all know by now, what's below it is the base layer, and that includes the refraction portion of it as well. So even though we have our refractions in this case set to be, you know, the default white refractions, if you will, you can see that they're still getting tinted because the light has to pass through that clear coat layer first, and the clear coat layer has a very specific absorption that's currently set, right? So if you make it red here, everything's going to get tinted accordingly, right? Now, if we drop the saturation, well, now we're essentially disregarding the absorption property of the clear coat layer here. It's just, you know, it's letting all the light pass through it. You were only adding that sort of clear coat layer on top, but it's not hindering any of the light transport, if you will, right? And this is all realistic behavior. Okay, all right. So let's just undo all these changes here we've done to demo just how realistic the absorption parameter is. Because, you know, that wasn't exactly the material that we set out to create here. You know, we went for this wooden material and not some sort of a refractive, edgy material, right? Right. So with that done, hopefully at this point, you're starting to realize just how useful the clear coat layer can be to you. If you'll recall, we started this clip with that raw wood material that we've set up exclusively through the base layer, right? But then, with the help of the clear coat layer, we started adding this clear varnish to it. And it was pretty detailed because we used all kinds of different roughness and bump maps, right? And then ultimately, you know, by using the absorption in a clever way, we've emulated this really complex violin wood material here. So hopefully you can see now that the clear coat layer can be of immense use to you when creating all kinds of different materials. And what's even cooler is that you don't need to mix and match the different kinds of materials through the layered Corona material to get this kind of effect. No, the clear coat layer is available to you from right inside the Corona physical material. It's all just a matter of toggling it on and playing around with its settings. All right, so that's it for this one. We hope you've learned something new here, and we'll see you in the next one.